Minerals are essential building blocks for the human body, each with unique functions that contribute to our overall well-being. They regulate vital processes like enzyme activity, acid-base balance, muscle contraction, and growth. A mineral's effectiveness is determined by its bioavailability. With the exception of iron, most minerals are optimally absorbed in their ionic form, separate from organic molecules and complexes. When minerals are bound to complexes, absorption becomes difficult, resulting in their expulsion through feces. Notably, minerals such as sodium, potassium, chloride, iodide, and fluoride have excellent bioavailability, greater than 40%, while others like iron, zinc, chromium, and manganese have lower bioavailability, only 1% to 10% is absorbed. Heme iron, found in meat, fish, and poultry, falls within the 20% to 30% bioavailability range. Two essential minerals, calcium and magnesium, fall into the medium bioavailability category, 30% to 40% absorption. When considering mineral consumption, especially with supplements, understanding mineral interactions is crucial. Some minerals can hinder the absorption of others. For instance, iron supplementation can impede zinc absorption, and excess zinc can decrease copper absorption. Similarly, an excessive intake of calcium limits the absorption of manganese, zinc, and iron. When minerals aren't absorbed effectively, deficiencies can arise. Minerals are broadly categorized as macrominerals, major elements, and microminerals, trace elements. Macrominerals are needed by the body in quantities of 100 milligrams or more daily. These major elements include calcium, phosphorus, magnesium, sulfur, sodium, chloride, and potassium. Microminerals are required in smaller quantities, generally less than 20 milligrams per day. This group encompasses iron, iodine, selenium, zinc, chromium, copper, and other minerals without established dietary reference intakes, DRI. Macrominerals. In straightforward terms, macrominerals are vital for adults in daily amounts of 100 milligrams or more. Let's delve into the specifics of calcium, phosphorus, magnesium, and sulfur. Calcium. The human body's most abundant mineral, calcium, has a multitude of functions. It plays a pivotal role in bone and teeth mineralization, muscle contractions, blood clotting, blood pressure regulation, immunity, and potentially guards against colon cancer. Our body skillfully manages calcium levels through homeostasis, ensuring balance. Depending on calcium levels, absorption occurs in various parts of the intestine. When calcium levels are low, the kidneys release calcium from bones. Foods like dairy products, fish with bones, leafy greens, and legumes offer substantial calcium. Unfortunately, many people in the US fall short of recommended calcium intake, leading to the popularity of calcium supplements. Calcium carbonate is cost-effective and a reliable source, while calcium citrate suits those with low stomach acid. Phosphorus. Coming in as the second most abundant mineral, phosphorus mirrors calcium's role in bone and teeth mineralization. It also aids kidney waste filtration, energy production from carbs, proteins, and fats, and supports tissue growth and repair. Additionally, phosphorus contributes to DNA and RNA formation and balances other vitamins and minerals. Meats, poultry, fish, eggs, beans, and certain breads are rich sources of phosphorus. Deficiency is rare in the US, except for individuals on specific medications. Excessive phosphorus can hinder calcium absorption, potentially affecting bone density. Magnesium. Abundant in bones, muscles, tissues, and fluids, magnesium is indispensable for bone health, protein synthesis, muscle and nerve functions, enzyme activities, and dental well-being. Nuts, legumes, whole grains, and leafy green vegetables provide ample magnesium. However, many Americans lack sufficient magnesium due to diets high in processed foods. Excessive calcium, protein, vitamin D, and alcohol consumption can elevate magnesium requirements. While magnesium deficiencies are uncommon, they can occur among the elderly and are linked to age-related issues and certain treatments. Depletion of magnesium is associated with chronic illnesses and heart rhythm problems. Sulfur. Sulfur contributes to essential compounds in the body, including amino acids, vitamins, and heparin. Meats, poultry, fish, eggs, beans, broccoli, and cauliflower are sources rich in sulfur. Deficiency in sulfur is rare, and symptoms are not readily apparent. Excessive sulfur might interfere with bone mineralization, but toxicity is infrequent. Now let's look at microminerals. Iron. Iron is crucial for cell growth, playing a vital role in the production of hemoglobin and myoglobin, muscle function, and energy production. Iron from animal sources, heme iron, and plant sources, non-heme iron, differ in absorption. Vitamin C-rich foods enhance non-heme iron absorption. Iron deficiency is widespread, especially among women and athletes experiencing blood loss. However, excessive iron supplementation can lead to adverse effects. Iodine. Iodine is essential for thyroid function and metabolism. It is present in seafood and iodized salt. Developed countries typically have minimal iodine deficiency due to salt fortification. A lack of iodine can result in goiter and cretinism, while excess iodine can lead to thyroid-related issues. Selenium. Selenium acts as an antioxidant in plants and supports heart health, immune function, and more. Plant-based sources offer selenium. Deficiency may lead to health problems, while excess selenium can cause gastrointestinal discomfort and other issues. Zinc. Zinc plays a crucial role in immune function, wound healing, senses, growth, DNA synthesis, and more. Meats, dairy, seafood, and nuts are excellent sources of zinc. Zinc deficiency can impair immune function and wound healing. High zinc intake may affect cholesterol levels and mineral absorption. Chromium. Chromium contributes to insulin function and glucose metabolism. It is present in foods like whole grains and brewer's yeast. Ongoing research is exploring its potential benefits for diabetes. Deficiency and toxicity of chromium are rare occurrences. Copper. Copper supports blood cells, nerve cells, the immune system, collagen formation, and energy production. Meats, liver, organ meats, and legumes are copper-rich foods. Genuine copper deficiency is infrequent. Excessive copper intake can lead to various symptoms. Electrolytes. Electrolytes, including sodium, potassium, and chloride, are essential for cellular function. They regulate water balance, osmotic equilibrium, acid-base balance, and cell differentials. While deficiencies are generally uncommon, excessive sodium intake is prevalent due to processed foods, and potassium deficiency can arise from low fruit and vegetable consumption. Now, how does our body digest and absorb minerals? Compared to vitamins, the digestion and absorption of minerals are intricate processes. In the stomach, digestive enzymes and acids separate minerals from other food components. Positively charged minerals, like calcium, iron, zinc, and magnesium, dissolve in the stomach's acidic environment. These dissolved minerals interact with hydroxide molecules and protein carriers, forming chelation compounds. This intraluminal process primarily occurs in the upper small intestine, known as the duodenum. Negatively charged minerals, or anions, are unaffected by pH and are easily absorbed via simple diffusion across the small intestine's border. In contrast, positively charged minerals and chelation compounds cross the border through facilitated diffusion, from high to low concentration, with the assistance of attached protein carriers and active transport, from low to high concentration, powered by ATP. The transport mechanism depends on the mineral concentration on each side of the small intestine's border. This absorption phase is known as the translocation stage. Once the mineral complex crosses this border, it enters the portal blood circulation, en route to the liver for processing and eventual distribution throughout the body. This phase is termed the mobilization stage. Certain mineral complexes may remain within absorptive cells for future use. Mineral bioavailability depends on various factors, including the presence of other minerals. This is because carrier proteins for facilitated diffusion and active transport are not mineral specific. For instance, elevated iron and zinc can impede copper absorption, while excessive copper can hinder iron and molybdenum absorption. Iron relies on transferrin for absorption, while other minerals use the nonspecific albumin protein carrier. These carriers can be overwhelmed by excessive minerals, leading to toxicity. Moreover, fatty acids in the intestinal lumen or high concentrations can impair mineral absorption by binding to them. While most minerals are absorbed in the small intestine, sodium and potassium absorption occurs in the large intestine. Minerals interact within the body in various ways, sometimes enhancing or inhibiting each other's absorption and utilization. Here are some examples of mineral compatibility and interactions. Compatible mineral pairs. Calcium and magnesium. These minerals often work synergistically. Adequate calcium intake can boost magnesium absorption, and vice versa. They both contribute to bone health and muscle function. Vitamin D and calcium. Vitamin D aids calcium absorption, ensuring efficient utilization for bone health and other bodily functions. Zinc and copper. Despite competing for absorption, maintaining a balance between zinc and copper is crucial. An excess of one can lead to a deficiency in the other. They both play roles in immune function and overall health. Iron and vitamin C. Vitamin C enhances the absorption of non-heme iron from plant-based foods. Combining vitamin C-rich foods with iron sources can improve iron uptake. Incompatible mineral pairs. Iron and calcium. Calcium can hinder the absorption of non-heme iron, found in plant foods, when consumed together. It's advisable to separate their intake by a few hours. Iron and zinc. High levels of zinc can impede iron absorption, especially when taking zinc supplements alongside iron-rich foods. Calcium and magnesium with other minerals. Excessive calcium intake can hinder the absorption of other minerals like magnesium, zinc, and manganese. Striking a balance is essential. Copper and zinc. Although both are necessary, high zinc intake can interfere with copper absorption. Maintaining an appropriate ratio is vital. Calcium and phosphorus. While both are essential for bone health, an excessively high calcium intake relative to phosphorus can disrupt the balance and affect mineralization. Final notes. Maintaining a diverse and balanced diet is crucial to ensure the right intake of essential minerals. If considering mineral supplements, it's advisable to consult a healthcare professional, as excessive intake of certain minerals can lead to imbalances and health issues. If you found this information valuable, consider giving the content a thumbs up. For more insightful content, don't forget to subscribe. Your support drives us forward. Thank you for tuning in, and see you in the next video.